Welcome to AP Calculus BC video for skill number 202. I can match equations with their graphs without the aid of a calculator and interpret the meaning of key points within context. Alright, this skill is largely a review of things learned in pre-calculus and calculus AB. At this point we really should be very comfortable with the 12 parent functions, so I'm going to cruise through them. The first is a linear function, and it has a domain and range of all real numbers. Most commonly the parent function looks like y equals x. It is a straight line. We could have transformations to the parent function, so that maybe we translated the graph up, or maybe we vertically stretched the graph. Next up we have the quadratic. Has a domain of all real numbers and a range of y greater than or equal to 0. This is y equals x squared, and you can see the parabola drawn to the right. Cubic has a domain and range of all real numbers, and we know it as y equals x cubed with a general curve shape like that. We can perhaps shift it off to the left. This might be a y equals x plus 2 quantity to the third. The next parent function is the absolute value function, and it consists of two straight lines, as you can see shown there. Absolute value. Let's scroll up. The reciprocal function, we're starting to get into some of the algebra 2 and beyond functions. The reciprocal function has two asymptotes. There's a horizontal asymptote at y equals 0 and a vertical asymptote at x equals 0. Hence domain is x cannot be 0 and range is y cannot be 0. The square root function starts at 0, 0 and kind of curves up and to the right. The exponential has a horizontal asymptote at y equals 0, so we never want to cross it. And if it's not transformed, it's going to cross the vertical axis at 0, 1. The inverse of the exponential is the logarithmic function, and the logarithmic function has a vertical asymptote at x equals 0. So the curve never crosses the vertical axis, and it crosses the horizontal axis at 1, 0, regardless of the base of the log. The base is basically going to tell you how flat of a curve it is. Next up we have some trig functions. The sine function starts at 0, 0 and does its curves. The cosine function starts at 0, 1 and does the same curves as the sine function, we just have it shifted. Then there's the greatest integer function. This one's less commonly used, but we'll see it in calculus, and the logistic function. On the skill test I probably will not focus on these two, but we should start to become comfortable with them, particularly the logistic function, because when we get into some of the later chapters in the book we will start to deal with this curve. I also wanted to hit on some common transformations to note. We do have a skill in a couple more that we really focus on transformations and looking at an equation and describing what type of transformation, or looking at a graph and coming up with the equation. But if we add a number to the end of that, that's a vertical translation. If we put a number, replace x with x minus h, that's a horizontal translation. If we multiply the function by a value, that's a vertical stretch or compression. If we multiply just the x by a value, that is a horizontal stretch or compression. And I'll get into the details of why it's 1 over b later on. If we put a negative in front of the function, that's going to reflect it over the x-axis, and if we put a negative in front of the x, it's going to reflect it over the y-axis. And again, I'm going to only touch on this at the most elementary level for this skill. I think it's skill 204, maybe 205, that we start to focus more on transformations. Alright, Stewart has a somewhat different breakdown for the 12 parent functions. We have the linear, and then he says the polynomials, which are like linear, quadratic, cubic. And then we have the power functions, which he subdivides into 3 different types of power functions. The first is where a is an integer, so we have like x to the second power, x to the third power, x to the fourth. That would be a polynomial. Next we have where a is equal to 1 over n. So for example, we might have x to the 1/3, and that's a root function. And then finally, if we have x to the -1, we know we could translate that as 1 over x, and that's the reciprocal function. So we also have rational functions, which are ratios of 2 polynomials, like x squared plus 3 divided by x to the 4th minus 9x plus 7. That's a rational function because it's a ratio of 2 polynomials. Algebraic functions are functions constructed with algebraic expressions, and this is easier to see by example, so I've provided 2 examples. The first looks like a root function, but because it's the root of a polynomial, we're going to call it an algebraic expression. And the second function starts to look like a polynomial, but then we've multiplied our polynomial, or a piece of the polynomial, by a root function. So it's kind of a way of connecting several different types of functions as long as it's only algebraic operations. We have the trig, the exponential, and the logarithmic. So the way this will appear on the skill test is I might say, sketch this function, and give you a very simple function to sketch. We see that this is a quadratic function that is shifted to the left 4. And since the quadratic function looks like this, we just move the curve 4 units to the left and call out the key point. I won't get more technical than that with the sketch, just a very loose approximation. Another way this can show up on the skill test is by classifying functions. So what I will do is I will show you a function and you'll say, hey, that's a logarithmic function, or a natural log function, which is a type of logarithmic. This is a root function. This is the 4th root, and then we have a rational and an algebraic. Alright, this concludes the video for Calculus BC skill number 202. Thank you.